law simply states that the sum of the currents entering a node is 0. And this holds for closed boundaries too, which we'll look at. But on the right-hand side, you'll see 4 different currents, 2 coming in and 2 coming out. So the 2 currents going into that node, the way they're drawn, are I1 and I4. And the two currents coming out of the node are I2 and I3. So in order to generate the equations, I like to put currents coming into the node on the left-hand side equal currents coming out of the node on the right-hand side. So that's the second equation down. I1 plus I4 equals I2 plus I3. Currents coming in equal currents coming out. On the top part of the line, you see a more direct representation of Kirchhoff's current law, which says that all of the currents coming in and out of a node equal 0. So I1 minus I2 minus I3 plus I4 equals 0. So again, if you look in the gray box, Kirchhoff's current law, the equation of that is saying for all of the currents coming into a node, if you take the sum of all the currents coming in and out of a node, I should say, and that sum of all of those equals 0. So we're going to look a little bit more of that in the next slide in an example. If V4, so the voltage over 4, the voltage across the 4 ohm resistor, is 8 volts, determine I1, and what is the current going down in that direction. And so we're going to use this circuit to be able to determine some of that. So I want you to try to solve it first on your own, and then we're going to go through ones to solve it, and then I'll show you a more simplified solution that the book has.